So I just wanted to take a look at 3 of these. Now, you're going to say, well, we already did number 1. Well, I just wanted to go over it again, okay? So I'm going to pretend that we didn't. So looking at number 1, these types of problems need to be looked at by, again, that number line is the critical, or the timeline is the critical thing that you need in order to really get your head around, I call it, what the problem is really asking. So in this particular one, seeing we've looked at it, now we've got a little bit of a sense on it. The scheduled payments of $3,000 is due today, and $2,000 is due in 15 months. Okay, so we've got that is a scheduled payment, and someone wants to replace it by 2 payments of $1,500 due in 15 months and a second payment of some mystery amount due in 24 months. So we've got a total. If we look at the total length of time here, it's today right out to 24 months. So what must the second payment be for the 2 streams to be economically equivalent? And all that's saying is, look, you got an agreement with someone to pay you some money. And the agreement is that they're going to pay you $3,000 today and $2,000 in 15 months. So we got to ask ourselves, what's that worth? How much is that worth? So we need really to think about what's that worth at some point in time. Let's say today, it could be some other point in time, but it doesn't matter. You got to ask yourself, what is that chunk of money worth at some given point in time? What they want to do is they want to replace that. They don't want to do that type of arrangement. They want to come up with another arrangement. And the other arrangement is 2 payments, one due in 15 months and a second payment of an undetermined size due in 24 months. Now, so you got 2 basic payments there. Option A, which is the original option that you determine, and then there's a new proposed option. So, for you as the person who's loaning the money, you want to make sure you get the same amount of money. So you're asking yourself, how can these 2 be equivalent? They got to be the same, right? So you want to be able to compare apples with apples and to say, okay, let's compare them. So what must the second payment be of the 2 streams to be economically equivalent? Assume that the money can earn 3% compounded quarterly. So with these problems, as I say, the number 1 thing you need to do is to draw a timeline first. And in order to make the problem, I'll call it easier to solve, and I'm just going to hop to it now. In order to make the problem easier to solve, you have to ask yourself, what's a good point of reference? What is a good point of reference on which to assess the time value of both of those payments? There's nothing to prevent you from picking any time at all, but you want to make the math easy. So the math is made easiest if you pick a point that is the point of, I'll call it the mystery point. In this case, the mystery point is 24 months. We don't know what the value is at the 24-month mark. We're looking for that. What should the final payment be on the 24th month? So if you pick the mystery point, that makes the solutioning of the problem more straightforward. Okay? So let's assume then that if we go back to the problem, that the mystery amount, an undetermined size due in 24 months, we're going to get the value of both sets of payments at that 24-point mark. Okay, that 24-month point, I should say. So what we're doing is when we draw out, unfortunately, I can't zoom this up. What we need to be able to do is to make stream 1 equal to stream 2. So stream 1 we've seen here is now $3,000, 15 months, $2,000. So that's the first stream. The second stream runs from the 15-month mark through to the 24-month mark. So seeing the mystery amount is at 24 months, let's say, okay, we know that, for example, if we look at these, we can take this $3,000 payment. I'll call that one. I'll just look at this one first. And if we bring that ahead 24 months, we can find out what is the value of $3,000 in 24 months' time. Okay? And then we ask ourselves, well, okay, we're going to bring ahead the other payment, the $2,000. We're going to ask ourselves, what's the value of that at the 24-month mark. In other words, 9 months after the 15th month. Okay, so we're just kind of bumping it up here. We're bumping it up. So that's 15-month, 24-month is 9 months. So we're going to drive that ahead. And we're going to drive this ahead. So at the end, just looking at this first one, what we're going to get is a value of the payment, the value of that payment, and the value of that payment at the value at the 24-month mark. So two of those combined together will give you the total value of the payment at the 24-month mark. Okay? Now, if we did that and we stop there, we say, okay, very good. Let's just stop there now, and we'll say what effectively that loan that we signed up, that original loan that we signed up for, the value of that in 24 months is $5,230.14. So someone comes to you and says, no, I don't want to do that. I want to do something different. And in this case, they want to do $1,500 in the 15th month and whatever it takes at the 24 months to balance up the loan. So you say to yourself, well, okay, what I need to do is to make sure that I get 52/30/14 under any scenario. So you need to say, okay, look, this $1,500 that you're offering me here in the 15th month, if I were to figure out what the value of that is at the 24th month, which is really bringing it ahead by 9 months, I would find the value of it to be $1,534. So this mystery payment then must be the difference between what I want total, 52/30/14, and what this $1,500 is going to be worth. So if I took 52/30/14, subtracted 1534, that would tell me that that's how much I'd have to get at the end in order to satisfy that loan. That's basically the logic behind it, okay? Without getting into percentages or the rates or anything like that, that's the logic behind it. And you got to understand the logic because the rest of it is just plugging numbers into a formula, okay? So I've just laid out here, deal first with the timeline one. We need to find the value of A and B payments at the 24-month mark. So that 24-month mark is called the focal date or the focal point. So here it is, and we know that based on the problem here, 3% compounded quarterly. So 3% compounded quarterly, we need to, we haven't seen quarters before, really. Quarters is the first time. There's 4 quarters in a year. I often have mental trouble with quarters. I don't know why. It's just me, okay? But it's 4 quarters in a year. So 9 months is really 3 quarters of a year. So there's 3 quarters here. So what we need to do is to figure, okay, the interest rate, we need to figure out what the interest rate is per quarter. So we do the math on that, and we would find that at 3% really is 0.75 or 0.075 there for the purposes of I. We basically calculate the value of I. We put that into our future value formula, which is really what we're doing. We're trying to figure out what the future value of this amount is, or this amount is. We're bringing it ahead 3 quarters, which is 9 months, and we just plug that through our formula, and we get 2,045.34. In other words, that's what that 2,000 will grow to, assuming 3% annual 3 compounds. We have to do exactly the same thing with the 3,000. We take the 3,000 and we say, okay, now how many quarters is that? Well, it's 24 years, 4 quarters a year. So, 24 months. I can't figure if that's months or years. 24 months. 24 months is, I think I made a mistake on my answer here because, again, I can't tell how many quarters are in a year. There's 4 quarters in a year, so that would be how many total quarters would that be? 24 months, 4 quarters in a year. So that's 6 quarters. Now I've written down 8 quarters. Uh-oh, I made a mistake. Sorry. So that's actually 6 quarters. I'll have to fix that. Anyway, regardless, the math.
That's what 6 you said?
Yeah, it was 6 quarter. And this is why I say you got to be careful on this. It's 24 months. There's 4 quarters in a year.
Yeah.
So that's 6 quarters. 6 times 4, 24. See where I got that? Where it's compounded quarterly, we got to figure out how many quarters.
So yeah, so it's 4 per year, right?
Yep.
And it's 2 years?
Okay, it's 24 months. The time period is 24 months.
Yeah.
Yeah. So we asked ourselves, how many quarters is 24 months?
6.
Yeah.
Yeah, okay.
I made a mistake here. That's where I mix this up. And so as a result, I've got 8 quarters. Anyway, stuff happens. But the math of it is right. Other than the fact that that particular number is wrong, the process is exactly right. So what we do is we've got our interest rate. What we've done is 3% per quarter. So it comes down to 0.75, which is there. That's the value of I, which is the periodic interest rate. We plug it into the formula. Now I used N as 8. N is supposed to be 6. And I'm not going to try to calculate that right now because it will take me 5 minutes to do. But anyway, so that times that to the power of 6 will give you a number close to that. Okay. So once you do that, you know that you got this total here. And then you say, okay, now I'm going to, that's the total amount of money that I have. And then I'm going to go and I'm going to say, okay, look, here's the second payment. And I got to do the same thing. I got to take this $1,500 and bring it ahead. So I do the math on that. That's $1,500 is the present value. The period is 9 months, which is 3 quarters. So I just plug it in here. I got this side done right. I know I didn't fool it all up. So I plug it into the formula, 1,500 to the power of 3. That gives me that. So it's $1,534. So essentially, A and B, the original stream payments come to that amount of money. And C plus D, well, I've calculated C here is 1,500. I don't know what D is, but it's 1,500 plus X. So 5,174 equals 1,534 plus X, and I can calculate the X. So the final replacement payment is $3,637, or roundabouts there. So the mechanics of it is right. But as I say, my number of quarters were off here. It's just one of those mental things I have with quarters. I don't know what it is. Okay, any questions on that? All the time in this, as I say, the key thing that I want you to be able to do is this here. This rationalization part. The rest of it is just numbers. Let's take a look at number 2. A 2-payment stream consisting of $1,750 due today and $2,900 due in 18 months is to be replaced by, okay, that's as far as I'm going to go there first. So what we have is really the first stream, and the first stream consists of $1,750 now and $2,900 in 18 months time. So we could draw a little timeline out for that. So it's $1,500 now, and or $1,750 now, $1,750 now, and $2,900 in 18 months. Okay, so that's effectively stream 1. I'll call that. And that's to replace by an economically equivalent stream comprising of an undetermined payment due in 9 months. So I'm going to take a 9 months mark there. And that's a mystery amount. And $3,000 due in 19 months. So we got something like this. Okay, we've got our first stream. Our stream 1 is now in 18 months. And our second stream is in 9 months and in 19 months. Make sure I've read it right. Yeah. So it says calculate the unknown replacement payment if the money is worth 9% compounded monthly. So it's 9% compounded monthly. Okay. Now, as I say, we got this, and we say, well, what do we do with it, really, in order to figure out this value? This is the value that we're looking at, okay? So, effectively, what we got to do is come up with some way of calculating that value. And the way we need to do it is to come up with what we call a focal point, okay? A focal point is the point of reference that we're going to use in resolving the problem. And as I said to you, the point of reference that we use, it's easiest to resolve the problem if the point of reference is on the mystery date. Okay, so the mystery date is the 9 month mark. Let me just hop here and see if I can, yeah. So what we got is stream 1 is $1,750, $2,900. And stream 2 is the 9 month mark and the 19th month mark. So as I just showed you, this focal point is going to be at the 9 month mark because that's the mystery. That's what I call the mystery amount there. So we do the same thing that we do in every one of these problems. And that is, okay, we found the focal point. What we need to do is take the known stream, in this case, the stream A, and find out the value of those payments at the date of the focal point. Okay? So $1,750 needs to be brought ahead to the 9 month mark, and $2,900 needs to be brought back to the 9 month mark. This will give us, added together, this will give us the value of this stream 1, the total value of at 9 months. And then we're going to compare that with this second stream offering. And we're going to say, well, look, we don't know what the amount that is going to be paid at 9 month mark, but we do know the amount that's paid at 19 month mark. So what we'll do is we're going to take this 19th month mark money and we're going to bring its value back to the 9 month mark. And that way, we're comparing apples with apples. Everything is relative to 9 months. The other known thing is the total of this stream 1 at the 9 month mark must equal the total of this, which is stream 2 at the 9 month mark. So stream 1, which is A plus B, that amount plus that amount, must equal stream 2, which is what I call C plus D. Now, there's one of those that's a mystery. Seeing we know 3 of them, we could figure out the third one by doing simple subtraction. Okay? So that's the basic theory behind resolving this problem. So anyway, we've got the future value we need to find of this one here. We need to bring it ahead. So we're going to do the math on that one first. So it is brought to the 9 month mark. So what we do is we bring 7050 forward 9 months. So everything in here, we're talking about things being compounded monthly, 9%. So if we were to take 9% and figure out what the value of I is, 9% divided by 12 is 0.75%, which is 0.0075. So that's what we're going to use here. So the future value is 1750. This amount brought forward 1.0075 to 9, which is 9 months. And that comes to a value of $1,871.73. So effectively, this $1,750 will be worth $1,871.73 in 9 months at the prevailing rate. So that's A done. Now we look at B. So we're going to take the $2,900 and bring it back. It's at the 18-month mark, so we're going to bring it back 9 months. So in this particular case, we're taking $2,900, bringing it back 9 months, plug it into the formula here for the present value, 2,900, 1.075 to the power of 9. That comes to 271139. So effectively, that one there is brought back. So this one here plus this one here is the value of stream A at this point. And you'll see that two of those added together comes to $4,583.12. Did you guys get something like that? Hearing nothing otherwise, I'll assume you did.
I got 42.98 for stream 1.
42.98. That should be off by more than what I'd like. Now I might have done a math mistake as well, but I think that I'm pretty good here. I don't think I added anything up wrong. Did this process the same? Did you use the same?
How many compounds was it?
Okay, well, it's 9 months. Right?
Yeah.
And it's compounded monthly, so that's 9 compounds.
9 compounds. Okay, that was my mistake.
Okay, 9 compounds. This is why I say sometimes that's the stuff that gets you muddled. It's not complicated. It's just I find that's where I make my mistakes on this in terms of it saying, oh my goodness, was it, quarters particularly drives me around the bend. I don't know why I have trouble with quarters, but I do. It's just one of those mental hang-ups that I have. But we're not dealing with quarters here. We're dealing with months. So if you do the math of it, the mechanics of it, it should be pretty straightforward. So if you understand the logic of it, so that's that first stream. The second stream, well, there's a mystery amount at 9 months, so we're not sure exactly what that is. So let's just leave that for a second. And we really don't need to worry about it because that amount, and the reason why we picked a focal point to here is, well, that amount is going to be the amount at the 9 month mark. So there's no need to do any present value or future value on it. We are at that value. So that's the mystery amount. So we're going to set that to the mystery amount. And then we have this, what I call value C, which is $3,000. $3,000 is in 19 months. We need to bring it back to the 9th month. So we got to bring it back. We got to find the present value of it 10 months earlier. So we do this. 3,000, 10 months earlier. So we find the present value is 3,000 over 1.0075 to the power of 10. And that comes to 278401. So effectively, that $3,000 is worth $2,784 at this date here. So we know that the total value of this first stream equals the total value of this second stream. A plus B equals D plus C, in other words. A plus B equals C plus D. So we know A plus B is $4,583.12. That's what we worked out right here. We know C, we calculated that to be $2,784. And D is a mystery amount. We don't know that. But if we know this and we know this, we can figure that out. The difference between this minus this then is $1,799.11. So D, in other words, that final payment or the payment that will be made at the 9 month mark must be $1,799.11 in order to allow for this to work. Does that make sense? What we've been doing over the past couple of days is looking at these final kind of more complex issues related to equivalencies and equivalencies within the concept of compound interest. So essentially, what you have in these types of problems is someone has made an agreement to do some repayment schedule. Okay? And that same person has said, oh, I'd like to change it. So effectively, that's the scenario that we have. And the question that is posed then is, if we change it, what should be the payments, or what kind of payment structure that would be equivalent to the payment structure that was already agreed to. So we need to make sure that the original structure is equivalent to the new structure. That's effectively what we're doing, the long and short of it. That's what it boils down to. In this particular problem that we're looking at today, number 3, Patrice defaulted on payments of $1,000 due 1 year ago and $1,500 due 6 months ago. So that was the original agreement, that she would pay $1,000 and $1,500 at the 1 year ago mark and at the 6 months ago mark. She didn't do that. The small claims court orders her to make 3 payments, $800 1 month from now, $900 4 months from now, and a third payment 7 months from now. We do not know what the third payment is. So the basic question then is, what is that third payment, and what does it need to be so that the creditor is in the exact same economic position as if the original payment scheme was in place? So what we need to do is to know what the rate of return is that we need to consider this at. So it's 4.2% compounded monthly. Okay. So what you need first and foremost to do, is to look at the timeline. So here's the timeline for number 3. Effectively, 1 year ago, $1,000 was supposed to be paid, and 6 months ago, $1,500 was supposed to be paid. And really, here we are today, and that's supposed to be paid today, and there is no money. So the court has said, okay, look, what we're going to do is rejig the payments so that you're going to do an $800 payment 1 month from now, a $900 payment 4 months from now, and a final payment 7 months from now that is indeterminate. So the question is, how do we resolve this? Well, with the 4.2% rate of interest, effectively what we need to do is to say, this is the area, this is the point that we need to bring it to, because that is 7 months from now, and that is the mystery date. So this is what's called the focal point. Okay, so we're going to solve everything to this point here. And essentially what we're going to do is we're going to say, okay, let's find out what the total value of these payments that was originally bargained for. What is the value of them at this point right here, the 7 month point? And we're going to figure out what that is at the 7 month point. And then we're going to say, okay, now we know that the original deal, the new deal has to match the original deal. In other words, whatever we come up with down here must match whatever this is here. So looking at the second stream of payments and the revised stream of payments, it was $800 1 month, $900 in 4 months, and a mystery in 7 months. So again, what we need to do is we need to bring forward this $800. Bring forward this $800 to bring it up to the 7 month mark. Bring forward the $900 to bring it up to the 7 month mark. And then say, okay, here's the mystery amount. Now, if we add the present value of this one here, when we bring it up to the 7 month mark, and the present value of this one here, and this one here, if we added up those numbers, that would come, or it needs to come, to the total that we've determined for the original payment. You follow me? Did I have a question out there? So that's effectively what we got to do. So as I say, the hardest part of these problems is this part right here. Well, let's just look at the problem then in terms of the math. And I'm not going to get too concerned about the math because that's stuff that takes longer to do, and you guys should be able to work on that now. But if you understand the logic of the timeline, the math becomes relatively easy. So what we need to do first and foremost, I call it step 1. What we need to do in step 1 is to find out the value of this original set of payments, this 1,000 and 1,500, And we're going to find out the original value of them at the 17-month mark, where that yellow line is. So how do we do that? Well, we need to calculate then the future value of these amounts brought ahead by the time that they're out there. So this 1 year ago $1,000, we got to bring that ahead 1 year and 17 months. Now 1 year and 7 months, which is a total. Okay, so that's a total of 12 months and 7 months. Okay, 12 and 7, which is 19. I have written down 17 by mistake. That's supposed to be a 19 there. I got a mistake made right off the bat. I can see I got an error made. That's supposed to be 19. I think my math is right. I just wrote down a 7 as opposed to a 9. So what we're doing here is we are taking this amount of money for the first one. So the first one, this $1,000, we're going to bring it ahead. And we need to find out what the value of it is at the 7-month mark. So what we're doing is taking 1,000, multiplying it by, it's 4.2%. It's a monthly rate of interest, or it compounds monthly. So that's 0.35% per month, which is 0.0035. So 1.0035 to the power of, I think that's 19 if I'm not mistaken. And that comes to $1,068.84. So that's the first one we do. We bring that ahead. This one here, the $1,500, we need to bring that ahead to the 7-month mark. So that's 6 and 7, which is 13 months. 6 months plus the 7 months is 13 months. It's $1,500. The interest rate is the same as 0.0035. We do the math on that, and that comes to $1,569.70. So that's A and B. And so let's figure out what the total value is of these things when we bring them forward. Well, the total value is $2,638.34. In other words, she needs to pay $2,638.34 in order to make that bill whole. Okay, in order to make the bill whole. The judges came out and said, okay, look, we're going to do a deal here where you're going to pay $800 in month 1, you're going to pay $900 in month 4, and a final amount in month 7. So what we need to do now is to say, okay, look, we know that we're looking at month 7, so that will be whatever that amount is. We need to take the 800 and bring it ahead 6 months, because it's at 1 month. Let's bring it ahead. And let's take the 900 and bring it ahead 3 months. And that way we get everything at the 7-month mark. Okay? So what we're going to do is, first one is this $800. We're going to bring it ahead 6 months. So down here, $800, 1.0035, which is calculated based on the interest rate, to the power of 6, which is a total of 6 months that it moves along. That comes to $816.95. So that 800 will be worth $816. Then we got to take that 900 and bring it ahead 3 months to bring it up to 7 months. So we do that. 900, 1.0035 to the power of 3. That's 909.48. The value of E is a mystery, but it is, the present value at the present time is the present amount. So if we took 816, 909.48 plus that mystery amount, it needs to come up to what we calculated to be the amount owing, which is $2638.34. So if we took this one, plus the mystery one, it would equal $2638. So then we can do the math on that. We can find out that the amount owing that has to be this last payment is $911.90. So that's essentially how you do those. And as I say, my primary interest in all this is to make sure that you can do the timeline. And the rest of it, you're prone to making errors on. And as I say, most of the time, this is done with computers now. The computers solve the tedium of it. But the understanding logic of it is critical, and you need to demonstrate the understanding of logic most important. And there is an understanding of the logic.